As soon as you say the topic is civil disobedience, you're saying our problem is civil disobedience. That's not our problem. Our problem is civil disobedience.
And I know how ridiculous it sounds because I thought it was the dumbest thing that I had ever seen, and I wouldn't even look at flat Earth, anything, for a long time because it just seemed so ridiculous to me. One day I decided I would go ahead and watch a flat earth video. I thought it would be funny. I thought I would laugh. At the end of the video, I was not laughing. I couldn't believe what I was hearing, so immediately I started doing my own research. I went to NASA, I went to space.com, I started downloading pictures of the globe and pictures of Earth and examining them. And almost immediately, I realized how inconsistent these pictures are and how fake they are. And they're not real. These are not real photographs. These are CGI. These are computer-generated images, okay? And it's very obvious when you start looking into it. Look at how different the sizes of the continents are from picture to picture. I mean, they can't even decide what size they want their continents to be. Take a look at this picture of the globe. It's pretty famous. Anybody can go download it. And if you take a close look at what's in the clouds. I mean, they spell it right out for you, and you can't make this stuff up. And it's not me photoshopping it. This is how it comes. Download it yourself. Also, look at this heat signature from the Earth. They say the Earth is facing the sun at a tilt, but the heat signature goes directly around the equator, right around the middle of the Earth. It actually pays no attention to the axial tilt, and that is what they tell you causes the seasons. The sun is actually farther away from the Earth during the summer months and closer in the winter months, but they tell you that the axial tilt is what causes the heat change. But here, that totally contradicts it. And if you look at this flat Earth picture, you can see that the heat signature is right in the middle, and that is exactly where the flat Earth model says the sun's path is. It circles above the Earth. I also started looking at all the moon landing photos and really scrutinizing them. And you can see, you know, even though a lot of it can be explained away, some of it just can't, like how close they are to the horizon of the moon. It just doesn't make sense. It should go far beyond where you see it going in the pictures. And look at the lander. The lander, I mean, they're supposed to take this thing out all the way to the moon and back, and it looks like it's got thin aluminum crinkled sheets all over it and tape and curtain rods, and it looks very thrown together. And if you look at the Moonlander foot, there is no dust in the Moonlander foot. I mean, it has a 10,000 pound thrust engine, and it didn't disturb any of the dust on the moon. This is a picture that I put together of various elements from the Moonlander and the moon landing, and you can take a look at the lander itself. Very cheap looking, very thrown together. It looks like it cannot withstand the going through a vacuum of space. It looks like it would just fall apart. You can see in the upper left, there's the blast crater that NASA says you can see from Earth, yet below the Moonlander, there is absolutely zero disturbance from it actually landing on the moon. No dust has been disturbed at all. There's no dust in the landing pads. There is no sign of the engine firing, no blackening of the exhaust tube. And look at the flag. They put this flag that's supposed to be there after they leave the moon, but they put it right next to the lander, again with a 10,000 pound thrust engine. When they leave, the flag would blow over. It would disintegrate. It doesn't make any sense for them to put it there. It's so staged. Here's a close-up of the picture of the wheel of the lunar rover, and there is no track in front of it or behind it, like it was just gently placed on top of the dust of the moon. This picture of the astronaut with the Earth in the corner, you can see that the Earth looks pasted into the photo and the background looks cropped out. Here the astronauts are, they don't even have any helmets on, and it still looks like they're on the moon. You can see this other picture of Stanley Kubrick walking with the NASA astronaut, a NASA advisor, senior administrator from NASA. It's circumstantial evidence, but it's very suspicious because we all know that 2001: A Space Odyssey came out before the moon landings happened. So Stanley Kubrick had clearly already perfected his technique on filming space scenes. A NASA astronaut practicing in the pool, and then him below in space. It goes on. I found some pictures from the Lunar Orbiter, and I did some Photoshop forensics, and you can see clearly where the images have been edited. Look at this one of the Earth. It looks rather large coming over the limb of the moon. And you do a little Photoshop forensics and you see where things were cut and pasted, and even the digital artifacts that you get to show up when you adjust the levels in Photoshop, they don't match. I drew a line here. It shows you clearly that the lines that you connect from the digital signature of the photos don't even line up. They're not parallel. This is a picture that somebody was clever enough to put together, showing that the space between the Earth and the moon can fit all these planets in between it, side by side, with room to spare even. And then the next thing you know, they show you a picture of Earth and its moon from Mars, and the proportions clearly don't line up, and it can't be explained away by optics. Now, I know all of that can be considered just circumstantial and it's not really enough to convince anybody, but let's do some thought experiments, okay? One day my son asked me, because he saw the moon in the sky during the daytime, how come if the moon is in space, we can still see it? And I thought that was a great question. The moon is 239,000 miles away. The size of Tycho crater is 86 kilometers, or that's about equal to 53 miles across. Now, the distance of the moon from the Earth is 79 times the width of the United States. If you think about it, why do you think that you are able to see something as small as 53 miles across with your naked eye from 239,000 miles away? It really doesn't make sense. You shouldn't be able to see that. That's like looking at your friend from 6 miles away and being able to see them. Now, take a look at the space station. They say that it's in orbit 220 miles above the surface of the Earth. One thing to consider with the space station is that it's out in space and there are extreme temperatures out in space. When it is on the sun side of Earth, the temperatures get very, very hot. When it is on the night side of Earth, the temperatures get very, very cold. So you have a very extreme temperature change every 45 minutes on all the equipment. It's a very hostile environment. And if you've ever looked into the SR-71 Blackbird, that jet that they said flew at the edge of space, every time that thing came down for a landing, it was leaking like a sieve, okay? And they have this space station that's been up there for years and years and years, and it's never blown a seal, it's never had a problem. It just keeps going on and on. Hot, cold, hot, cold, hot, cold, without any effect. The other thing to consider is the size of the space station. They say that it's roughly the size of a football field. Here is a comparison picture of the space station compared to the size of a passenger jet. Now, when you look at a passenger jet flying at cruising altitude, you see it every day. They are about 5 or 6 miles up in the air. Now, imagine if you put this object at 220 miles above the Earth's surface. That is 44 times as high as cruising altitude for a jet. And even with a telescope, I don't see how anybody would be able to see that. The formula to calculate the Earth's curvature is 8 inches per mile squared. So at some point, when you're looking at things off in the distance, they should drop below the Earth's curvature and they should begin to curve away from you. But this doesn't happen. You can look at these pictures of the Chicago skyline, and at 56 miles away, it should be 2,000 feet below the Earth's curvature, and you really shouldn't be able to see any of these buildings, but we can see it. People also like to say that they watch boats disappear over the horizon because of the Earth's curvature, but is that really what's happening? If you look in this video, you can see that the zoom brings these boats back into view, where when you're looking at it with your naked eye, it looked like there was nothing there, but then here come these boats back into view. So clearly, they're not disappearing because of the curvature. They're disappearing because of the limitations of the human eye and also perspective. At some point, we really need to be honest with ourselves about the observations that we make about the world we see with our eyes. Do things disappear into the vanishing point on a flat plane, just like we're taught in art class, or do they curve away from us on a ball? Do we ever really see the curvature? Have you seen the curvature? If you watch some high altitude balloon footage, you'll see that if it doesn't have a fisheye lens to give the artificial impression of a curvature, there really isn't one. And this is the most irrefutable proof in my eyes that we do not live on a ball. If there is no curve, then there is no ball. Period. That's all there is to it. It doesn't matter if you're on the ground. It doesn't matter if you're on a mountaintop. It doesn't matter if you're 20 miles high in the sky. The horizon never curves away from you. It never gives the impression of being on a ball. It only gives the impression of being on a flat, level plane. Again, high altitude balloon footage, 20 miles up in the sky. ISS is 220 miles up in the sky. So this times 10 or 11, when does this turn into this? When does it happen? Or does the horizon always remain at your eye level? Does it always look like it's just right there in front of you? There is no curvature, none. Let's talk about water. The natural physics of water is to find and maintain its level, or the natural physics of water is to stick to a spinning ball. How does water behave in the real world? What do you see? Now, I know a lot of people like to say, well, gravity keeps the water stuck to the ball. And okay, let's talk about gravity. Gravity is the invisible force that keeps everything stuck to our spinning ball. Now, according to Newton, every force should have an equal and opposite force, but what is the opposite force of gravity? Well, they tell you that the opposite force to gravity is the centrifugal force of the spinning ball. Our Earth is spinning on an axis, and just by the very nature of the shape of a ball that is spinning on its axis, the centrifugal force differs at each point on the ball, being greatest at the equator, 1,650 kilometers an hour or 1,040 miles per hour, faster than the speed of sound. Then as you move up or down in the latitudes on the ball, it gets slower and slower. Thus, the centrifugal force is weaker as you get towards the poles. Therefore, it is counteracting gravity less and less as you get towards the top or towards the bottom of the ball. So why aren't the people at the North Pole being squashed like bugs? How are they even able to walk if this force of gravity is pulling them towards the Earth and there is no longer a centrifugal force counteracting gravity? How can they even pick themselves up off the ground? How about the constellations? The stars rotate around the North Star, Polaris. We see the same constellations throughout the year, just in different positions. Some people think that this proves that the Earth is a sphere, but I think it proves that the stars rotate over our head. Here is the sun in space. Here is the Earth. The Earth orbits the sun while spinning on its axis. At night, when we are not facing the sun, we see the stars in the dark part of space. Why don't we see completely different constellations 3 months later when we are a quarter of the way through our orbit? Or how about 3 months after that when we are on the opposite side of the sun? Every 3 months, the constellations should be completely different, but they aren't. All the ancient cultures and all the ancient texts describe a flat, motionless Earth. So what happened? What changed? Who decided that the earth was a ball?
Of ancient Egypt, I've inserted 2 sticks or obelisks, one up here in Alexandria and one down here in Syene. Now, if at a certain moment each stick casts no shadow at all, that's perfectly easy to understand, provided the earth is flat. If the shadow at Syene is at a certain length, and the shadow at Alexandria is the same length, that also makes sense on a flat earth. But how could it be, Eratosthenes asked, that at the same instant there was no shadow at Syene and a very substantial shadow at Alexandria? The only answer was that the surface of the earth is curved. Not only that, but the greater the curvature, the bigger the difference in the lengths of the shadows. The sun is so far away that its rays are parallel when they reach the earth.
Wait a minute, how did Eratosthenes know how far away the sun was? To make this measurement, you have to assume the sun is extremely far away and that the sun's rays are parallel. But how do you look at things like this and get that the rays are parallel? Because it certainly doesn't look that way to me. If you look at the crepuscular rays of the sun coming through the clouds, you can see that it looks like the sun is right behind the clouds and the rays are emanating from the source of light, and those rays are not parallel. The most commonly accepted flat earth model has the sun small and close and circling over the earth. If you use a lamp and 2 objects of the same size, you can see how the same effect Eratosthenes saw can be created. Dr. Auguste Piccard was the first man to reach the stratosphere at a height of 75,459 feet, and this is how he described what he saw. This is before NASA and the Air Force. What about the moon? Does it really reflect sunlight like they say it does? Pay attention the next time you see a half moon in the sky opposite the sun. If the moon really reflects the sunlight, why isn't the moon full if it's facing the sun? Is there really a Hubble telescope in space, or is it just a telescope flying around in a jet? Are they telling the truth about what they show us, or are they laughing at us? If you pay attention, you will see their mistakes. Are we really making progress, or are we being held back? Once prosperous countries are being bombed into oblivion. Children are starving all across the plain, and the powers that should not be spend billions on ushering in their new world order. NASA and their deception is the tool they use to keep us from knowing the true nature of who we are and where we live. They don't want us to know our true potential. They don't want us to know that we don't need them. They want us ignorant and docile, so we keep mining their gold. The globalists need a globe. Once you realize that they don't have one, you can take the power back. Lies. Deception. Deception.
Man, Brian Mullen came out, put out some video that completely debunks the ISS. And I'm going to break it down for you right now, because that's a 30-minute video. And I just finished watching it. I mean, look at those likes to dislike ratio. I mean, you'd expect that from a guy who has a degree in engineering. He teaches physics. He can apply to be a teacher of physics, and he's debunking the ISS. So nobody's on there telling him his math is wrong. It's funny how that works. So we're going to jump right into this, and I'm going to give you a little overview of what he said in this video. Okay, remember the layers of our atmosphere? Did you forget about those? We got the troposphere, stratosphere, mesosphere, and the thermosphere, right? So the stratosphere is a little bit warmer than the troposphere. And then the mesosphere is a little tiny bit cooler than the stratosphere. And then suddenly, out of nowhere, the thermosphere becomes an oven. And it gets really hot, really hot. So I was wondering, isn't the ISS orbiting around in the thermosphere for what it seems like 16 years now? It's been orbiting around in this literal oven. So let's see. Let's take a look at this. We have the thermosphere, which starts at 100 kilometers, ends at 600 kilometers, right? That's what your little science textbooks say. And we have the mesosphere, which is colder, so those particles are closer together, right? And then the stratosphere is a little bit warmer than the mesosphere, right? That's what the graphic was showing. So now let's put the ISS into the picture. How high is the ISS in the atmosphere? 249 miles. Great. Now let's convert that into kilometers, and we get just about 400 kilometers, right? So let's put that in here. So now the ISS is in there. See all that sun? That yellow background is all the sunlight. But for some reason, according to illogical science, the ISS just reflects all of that sun away. I mean, shouldn't that be a red dot? Shouldn't it be receiving the heat? I mean, how can you resist that temperature? What kind of materials is that? I want to know. So let's go back to our little science book, find out exactly how hot this thermosphere is. And it says the solar minimum is 800 degrees Kelvin. And the solar maximum is 1200 degrees Kelvin. So let's convert that, find out it's 980 degrees Fahrenheit to 1700 degrees Fahrenheit. I mean, that's pretty hot. The ISS has been orbiting in there for 16 years now. Some reason it's 72 degrees and sunny in the ISS, where they film in colored shirts and long pants. But meanwhile, the temperature is 800 to 1700 degrees outside. Do you know how hot that is? I mean, you set your oven to, what is it, 450 to bake cookies? Now let's double that, and then let's triple that. I mean, we could even quadruple that if it gets really hot out here in the thermosphere. Scott Kelly be a honey baked ham right now. shouldn't he? He was in space for a year in that temperature. I mean, how good is metal as a conductor? You tell me. Metal attracts the heat. It's a great conductor. So help me understand why this dot doesn't get hot. Is there an invisible force field around it? Because that's your logic. Every particle in the thermosphere is super, super hot. But for some magical reason, the ISS stays perfectly temperatured, even though there's no air conditioning. So obviously, something's not right here. And if you want a more detailed explanation of what I'm talking about, watch Brian Mullins' Balls Out Physics episode 4, the ISS satellites in the thermosphere. And you'll understand it perfectly. So I'm calling BS on the ISS orbiting around in an oven. I'm calling BS on Scott Kelly, who should be a honey-baked ham.
If a pilot is flying around the curve of the Earth, then he should be dipping the nose down every 5 minutes. He should be dipping the nose down to stay around the curve. But the thing that really got me interested was, as you say, the gyroscope. In a plane, there is an artificial horizon, okay, and it's based on a gyroscope. And if you spin a gyroscope on a surface, it will want to stay upright. You can twist and tilt the surface as much as you like. The gyroscope will stay upright. So if a plane has a gyroscope and it starts following the curve of the Earth, the gyroscope would stay upright, which means the artificial horizon will start to roll backwards. But it doesn't. That's absolute proof that a plane flies over a flat surface rather than a curved one. Because I asked the pilot on my last flight, do you ever notice the artificial horizon rolling backwards? He said, no, but the artificial horizon has complex electronics in it to make sure it knows where it is on the Earth and it compensates. But I went to the manufacturer of the artificial horizon and they confirmed to me that it's completely mechanical, nothing electronic in it whatsoever. So it's literally just a gyroscope that can freely move. So that right there is proof to me that planes fly over a plane. None of it makes sense. The problem is that we're taught as children, this ball Earth lie, and you might ask as a child, what about the people in Australia? They're standing on the bottom of the globe, won't they fall off? And your teacher says, no, gravity. And you go, oh, okay. And you never go back to that question. But when you go back to it as an adult and start looking at it with a critical eye, right, the whole thing falls apart. As you say, the globe is spinning at 1,000 miles an hour. Neil deGrasse Tyson, who's a leading astronomer in America.
I'm Neil deGrasse Tyson, bitch.
That the Earth is not a perfect circle. It is actually an oblate spheroid. It's squashed and wider at the equator. Yeah.
So Earth, throughout its life, even when it formed, it was spinning, and it got a little wider at the equator than it does at the poles. So it's not actually a sphere. It's oblate, and officially it's an oblate spheroid. That's what we call it. But not only that, it's slightly wider below the equator than above the equator.
A little chubbier.
A little chubbier.
Yeah.
Chubby's a good way. It's like pear-shaped.
So my question to him would be, why is there land at the equator? Because water will move more readily than rock. So if the Earth is spinning, the water will be collected at the equator. I mean, if you spin a wet tennis ball, the water shoots off at the equator, essentially. So all the water will be gathered around the equator. So why is there land at the equator? Doesn't make any sense. The other thing that's about the spinning Earth is looking at the stars. Now, directly above the axis of spin is the pole star, Polaris, okay, directly over the North Pole. And we're told that the reason that all the stars spin around the North Star is because the Earth is spinning at 1,000 miles an hour. Okay, seems to make sense, because if you put a long exposure camera pointing at the North Star, you'll see the stars will make perfect circles around, perfect star trails. The only problem is the Earth is also orbiting the sun at 67,000 miles an hour. Okay, the sun is moving, dragging the Earth and all the planets up that way or that way at 600,000 miles an hour. So why do we see perfect circles? You know, because that's the slowest speed, that's slowest motion in that mix, and yet the Earth is moving 67 times faster that way and 600 times faster that way. So you should see the stars do all sorts of strange motions, but you don't. You only see them make these perfect circles. That tells me that it's the stars that are moving, not the Earth. The thing is, what the scientists will give you is calculations and and theories why that happens. But we have experience. We see things and they either make sense or they don't make sense. And what the scientists do is substitute our common sense and our intuition for calculations and theory. And we're supposed to believe the calculations rather than what we experience ourselves. There was a famous experiment back in the 1800s in England called the Bedford Levels experiment. Now, the Bedford Levels is a canal that is perfectly straight for 6 miles. Okay, so what a chap called Samuel Rowbotham did was he took a telescope, put it in the water about 8 inches above the water, and he had a friend, in a rowboat with a flag on the back, row all the way to the other end, and he was able to see the flag on the back of the rowboat the whole distance. Now, according to spherical trigonometry, the curve of the Earth is 8 inches per mile squared. So over 5 miles, that's 5 times 5, 25, times 8, which is 200, works out, that's 200 inches, which works out at 16 feet. That means the boat should have been 16 feet below the horizon. He shouldn't have been able to see the boat. Now, the scientists will say, oh, refraction and this and light bending around the Earth and stuff. But the fact is, it's perfectly flat. And he in his book, he puts forward many arguments that show that, or many experiments that show the Earth is always perfectly flat. They say that you see the mast, go down last. Is literally just the way your vision works. Yeah, it's perspective and atmospherics basically. The limit of your vision is supposedly 3 miles. And then after 3 miles, you're supposed to see the boat start to go over the horizon. It's funny that Neil deGrasse Tyson again says that, explains that you can't see the curvature of the Earth from a plane. He says this, you can't see the curvature of the Earth from a plane because you're not high enough. The Earth is so big that you can't get high enough to see the curvature. Yet you can apparently see a boat go over the curvature over the distance of 3 miles, which doesn't make sense. The thing is, when you look out and you see a boat start to go over the horizon, if you suddenly get a pair of binoculars and look, it comes back again. And once it goes out of the sight of your binoculars, if you get a telescope, it comes back again. It doesn't go over any curve of the horizon. What we found, many people have done experiments with very high-powered zoom cameras, and they've watched a boat sail out to sea, and they've just kept trained on this boat. And what they see is, after a very long distance, you see an atmospheric effect where the bottom of the boat disappears and starts, and the top of the boat inverts, so you see a sort of mirror image. And that, with your eyesight, basically the bottom of the boat just melts into the horizon. One of the best examples of that is the Antwerp Notre Dame spire, which can be seen something like 240 kilometers away from the spire. So that should be over a mile below the horizon, and you can still see it. There's been a few famous examples just recently of a man who took a picture across the Great Lakes from Michigan and was able to see, I believe it's Chicago, which he shouldn't have been able to see. And the television station basically said it was a mirage.
This is from Joshua Nowicki, and what you're seeing here is a mirage. We typically would not be able to see this from the Lake Michigan shore. We talked about this last night. Conditions are right on the lake that we're actually seeing a mirage of the Chicago skyline.
But they always say it's a mirage, but for a mirage to happen, you have to have very specific atmospheric conditions. And there have been so many people who have seen exactly the same thing on different days, different seasons, always the same. It's not a mirage. It's simply that you're looking across a plane. You see in a kind of pyramid shape. Yeah, you have a horizon at your eye level, and everything above the horizon will go down into the horizon. Yeah, everything below the horizon will seem to go up. Just like if you're in a long hallway, you'll see that the walls will start to move in, and the roof and the floor will start to move into the center. Yeah, so literally between you and the object you're looking at, there's all sorts of things, sort of like waves going up and down, and while you can't see them if they're beyond the limit of your sight, sometimes they can still obscure what you're looking at. But it's just because they're between you and it. And it's just the way, it's literally perspective. It's better if I could draw a diagram, but it's a very difficult subject to get your head around if you're not used to it. But it is perspective. One sort of other proof is there's a place in Bolivia called Salar de Uyuni, which is a salt flat. It's literally 100 miles wide one way and 80 miles across. And it's perfectly flat. And when it rains, literally you get an inch of water and it looks like a perfect mirror. Now, how does that happen on a sphere? Yeah, it shows you that, if you're one end of this salt flat, you can see perfectly clearly the other end 100 miles away. So it's just showing you that, the Earth is flat, and without the effect of the waves in the sea, you'll